thank you very much for coming to this talk. Small room, and it's going to be, I think, like we are family here. So, yeah, the talk, the title of the talk is "Grow Your Product and Save Both Time and the Money." So, before we start, it sounds a little bit like a selling pitch, like not a techie talk, but in fact it is tech talk, and but it will have a little bit of let's say sales pitch inside, because I want to tackle some of the questions that we usually don't tackle in tech. So why the title and why the talk? Basically, over some period of time of my experience and working in IT industry, especially here in Serbia, and because I'm coming from nearshoring and from consultancy companies, I think that we here in this market, we are mainly focused on delivering the work and delivering the product that is asked from us, but we are not introduced good enough to the prices and to the money of how much do we cost, not in the terms of hourly rates, how much our companies are charging for us, but how much does it cost that specific thing that we are building. So, and especially with the when I was reading the Lean Startup book by Eric Ries, I was also thinking, like, when I was reading that book, I was pissed off, because I bought that book with, okay, this guy is like, he wrote the Bible, so let's read it. Everybody's talking about it, and while I was reading, he is giving a bunch of advices what you should monitor and how you should build your product, and I was thinking, like, you cannot build this thing unless you have like a couple of millions of bucks in your pocket, because it costs more to monitor your product how he suggests than actually building the product. So yeah, I lived with that in my mind for a couple of let's say years, and then I started working on a company that's actually kind of building the product, and then I realized, okay, that can be done actually for some, let's say, not that expensive money. You can actually do it reasonably cheap. So I wanted to share my experience with you guys, with the local community, because as I said, I think we don't know much enough, we don't know enough about that, how actually, how much we cost from the infrastructure point of view and similar stuff. So let's start. Blockchain, right? I have nothing to say about blockchain, but it's all the hype, so I had to put it in. So we are moving on. I'm coming from a company that's called Kazumo, and Kazumo is basically online gaming operator, online casino, if you will. Kazumo is a Swedish company based in Malta, and it's just starting with producing its own games, but it's mainly an integration platform. So basically, Kazumo integrates games produced by other gaming providers. And yeah, people come and people play those games. And I'm part of the team that is called DEA, which is a short term for data engineering and analytics. And we had some problems to push that as an internal brand inside the company, but finally we made it. So now we are DEA. And it kind of makes sense also when you think about what we are actually doing inside the company. And so the team is consisted of 10 people. At the moment, it's 8 data scientists, data analysts, and 2 data engineers. Now, I would like to invite you to pay attention to the ratio of scientists and analysts to engineers, only 2 engineers. And I will later show you the infrastructure that we are handling and the things that we are doing. So keep in mind that's only 2 guys that are actually maintaining the infrastructure. And this is like a smooth intro into building the product for not so much money and with not so much effort. And I want to tell you a little bit starting story of how the big data platform, that's the product that we are building, actually started inside the Kazumo organization. So the whole story starts in 2014. Kazumo is older than that, but the big data platform, BDP as we call it, starts in 2014 when the current BI solution is slowly dying, and that current intelligence team, let's call it that way, is performing analytics in, let's say, suboptimal way. So how they did it? They took the dumps of the data they wanted to analyze, they transferred it to their laptops, they performed analytics, they produced a bunch of artifacts in a form of, I don't know, PDFs, infographics, presentations, and then they were sharing those files with the business people. And that's not the way to go. You cannot be fast, and you cannot make decisions in time when you're doing things like that. So the idea is born that we need reactive, we need a fast way of making decisions based on the data that we are gathering as a business. And we said, okay, but what we need in order to build that product, that analytics platform, first of all, we need to gather data in one place. And how we are going to do that, because the casino is already operating at that time for 2 or 3 years, and it's already massive amount of data that we have, and it's growing every day. So we did a little bit of calculation, and we realized that because we don't want to have our data center, we want to do it in the cloud. Let's transfer that to the cloud somehow. And then we did the computation calculation, and we realized that with the current bandwidth and the current situation of the data size, we would need full 2 months of full 100% bandwidth usage to upload that to the place where we can actually then start using it. So that wasn't the way to go also. So what we did, does anyone know actually what this great thing is? Exactly, yeah, that's the snowball. So what we did, we changed the format of the data, we shrinked it, and we shipped it physically to Amazon. So basically this thing is one big box where you put your data in, immediately encrypts it, and you ship it back to Amazon. Then they plug it in somewhere in their data center, and voila, you have your data in S3. So we joked at that time that we were the team that actually brought the snow to Malta, which doesn't happen very often over there. And yeah, a couple of fun facts, let's say. We are dealing with 55 billion events in total. I will tell you why I'm calling these things events. And that translates roughly to 15 gigabytes of compressed information over the day. And it's around 67 millions of events per day. Those numbers grow as with, I guess, any business. If the numbers go down, then problem. But for us, it's I have to make a disclaimer here. It's only data that is coming from inside the Kazumo. We are dealing with larger sets of data that are coming from, I don't know, Facebook, Google, MediaMet, and the other third-party integrations. But these are information that are coming only from inside Kazumo. And this is how the graph of our data growth looks like. So you will notice that we had the problem here. That was production issue. And you will see that we can have problems later a little bit. And that's where you have two opposite business requirements, which are equally important. And one is marketing, which is trying to push for more and attract more people. And the other is trying to be compliant. Basically, marketing campaigns do not play well with implementing solid anti-money laundering processes and basically asking from people a bunch of papers to prove that they are not doing crazy stuff. So yeah, collisions happen, I guess. But And this is what the EA team actually does. We are producing a bunch of dashboards, and we are mainly focused on monitoring the business success from the inside. So this specific dashboard is, as it says in the corner, you maybe see it, it's an NDC drill down. And NDC is abbreviation for newly depositing customer. That basically means that we, in this specific dashboard, we have a couple of graphs that are telling us the story about the customers that just registered for our product and deposited for the first time. That's what NDC is. So we have a breakdown by by type, by where they are coming from, so which campaign or which affiliate maybe, and by country and other stuff. And this is also what we are building. So this is more on the analytics side. That's what our data guys, data analysts and data scientists did. So for example, Hot or Not is a widget, a tool that takes some market information from various sources and takes information from inside the Kazumo platform and tries to guess which days are good for sending the marketing campaigns and which days are not. For example, that's heavily relying on geolocation of the player you are trying to targeting, because you have to take into account payday. For example, in Sweden it's a different day than in, I don't know, in Germany, so you are thinking about lots of stuff. And the KPI wheel, it's something that for example, if you click on one part of that wheel, it's one specific KPI, and the wheel is going to spin, and some things are going to pop up and other things are going to go to the back, and you will see how that specific KPI influences other things and which other things are influences that thing. So kind of a relationship model between the KPIs in the company. So that's what we are doing as a team. And this was the short introduction of the product. So the big data platform is basically the infrastructure, and the platform, as the name says it, that has to support building those things. And to go a little bit into our infrastructure, before I actually give you some insights, how much does it cost and how it looks like, I want to separate Kazumo into two different logical areas. On the left, or your left, there is a box which we are going to call Kazumo gaming platform. That's where the players are actually playing the games, and where all the betting and winning is actually happening. So these are a bunch of microservices, so we also check that point. We are super cool, we are doing the microservices part. And they are, of course, they are polyglots, so there is Kotlin, there is Java, there is Scala, there is who knows what. And they are communicating, they are sending messages to each other, and that is happening over the broker, which is RabbitMQ. In the RabbitMQ, there lives one little service that is consuming all of the messages that are happening over there. Those messages are actually the events that I was referring to previously. And that big data service is pushing all those messages, all those events to AWS Kinesis. And Kinesis pushed that forward. There is 3 question marks next to Kinesis because we are thinking about switching Kinesis and introducing Kafka. But we are not there yet. So Kinesis is over there for the live stream. And there is how it looks like is that microservices, before they are pushing the live stream of data to RabbitMQ, they are also persisting all those messages into some sort of storage, some sort of event store. And there is where we call it batch uploader, the batching service comes in. So if for any reason we have a breakdown of the Rabbit, we don't care about that because we are picking up the messages from the event store. That is single source of truth, how they call it. And we are batching those messages into EMR, Elastic Mapreduce. Do you guys know what Elastic Mapreduce is? Okay, then I have to explain it a little bit. So Elastic Mapreduce is Amazon service that basically serve you the Hadoop infrastructure. So you are able to spawn the clusters and shut them down as you need them, and to run Spark and Hadoop applications in those clusters. So we are using EMR to do a series of computation and series of ETL computations, transformations, how you call it, before we actually use that data, because the data that we are getting from the event store is how we call it, the raw data. It's unstructured. It contains a bunch of things that we actually don't need and don't want to pollute our tables that we are actually using for learning about the business performance. So that's where we are using EMR to transform that raw information into more structured, useful information. And we are pushing that to S3 as a long-term storage, cheap long-term storage. That's again AWS service. It's, I think S3 stands for Simple Storage Service. And this is how our part of computation, of the infrastructure looks like. So that's the cloud. In this picture, this is the cloud broken down. And again, I'm postponing the money talk in order to give you the explanation, to give you the potential complexity of the system, because we are talking here about distributed system. First, distributed things are happening in Rabbit, and those messages are asynchronous, so you cannot really rely on that the thing actually happened when you think that the thing happened. So you cannot rely on that. So Kazuma on the left is the gaming platform. Information comes through Kinesis in this case, and through Firehose Lambda, which is pushing the data to S3 that we covered. That's where we have the raw data in storage, in files, let's call it that way. And then when those files are created, we are using again one service in Amazon that's called Simple Notification Service to trigger our data pipelines. Data pipelines, we can understand them as more or less complex computations and transformations on the data that we have. Basically, let me give an example. That's going to come later. So the computations, when the computations are invoked, a bunch of them is happening. Some of them have to go in the beginning of the computation chain. Some of them have to wait the previous ones. Some of them are totally independent. So in this case, I just ask you to imagine, like, let's say 50 to 100 different computations that are happening on the data. And then we are using EMR through Spark to push that into Sisense, which is our business intelligence solution. And we go back and forth, maybe in a couple of circles, to finally push that data to Redshift, which is, again, fully managed Amazon warehouse. Now, fully managed, that's the key term in this case. We are not maintaining that. Amazon is, that's their thing. So we just say we need 10 nodes in Redshift, and we don't care where those nodes are. We just care if they are healthy or not. So that's minimal work on us, and that's important. That's important part. So in this case, I want you to remember the fully managed services. That's that's the card we are playing on. And again, big data platform is also polyglot. It is, I think, majority of the things are written in Python and in Scala, and I think we have some Java. I don't know, maybe. I haven't seen it for a while. I was actually hired in Kazuma as a Java developer, and I think I never wrote a single line of Java. So it's Python and Scala most of the times. And this is one example of the computation. So it's small, it's kind of ugly, but I will tell you what it does. It takes some information from S3, it performs a series of transformation of that information that in S3, it puts it back in a different place in S3, it may be persisted in a Hive table, that's again Hadoop ecosystem technology, and then it moves that data from S3 to its final destination, which is Redshift. And it takes, this specific one, I think, takes, I don't know, hour and a half. So, and yeah, and the number of computers that are doing that is 10 nodes in Redshift, at least 5 to 10 nodes in EMR clusters. Who knows how many EC2 instances? And I would like to ask you, what do you think? How much that costs? Rough guess. 100 euros, 1,000 euros, 10,000 euros. This is how much it costs. So I hate to look like AWS affiliate here. I'm not trying to sell their product. I'm just giving you the example of how building the expensive and complex product can actually be cheap in these days today. So it's between half a dollar and $7 per hour. So, but I have to say, this is not running every hour without stopping. This is running once per day or something like that. So it's a batch computation. So basically, for a day, for performing this, we are paying $7. It's it's $200 per month. I think that's okay, right? But now I want to emphasize once again why I'm trying to pass this message to you, because in my experience here in nearshoring, we had a number of projects that I know about that we were thinking that the infrastructure is super expensive, that's the most costly thing, and it's actually not true. I think that actually people are the most expensive, and you are going to see how you manage the infrastructure. So this is our computation infrastructure. When I'm speaking about this infrastructure, that's the infrastructure that actually we maintain. That means that we actually, when something goes down, we actually try to fix it. I'm not talking about the Redshift cluster, which is like, as I said, fully managed. I'm not talking about Lambda functions. There are similar paradigms in Microsoft Azure cloud. But so we are not talking here about that. We are talking about the computers that we actually care about, and the computers that we actually kind of wake up during the night if something broke down. So on the left-hand side, you have two EC2 instances, and they have like a dotted border. They have dotted border because now it's 12 minutes after a full hour, and at this point they exist because I know when they are scheduled to start. And they are going to exist for at least, let's say, 15 to 20 minutes, and then they're going to shut down. So if I was giving this talk in, let's say, 25 minutes to 1, I would say that these two EC2 instances don't exist. On the right-hand side, there is our computation infrastructure, basically the EMR clusters, which come and go. This is how it looks like. So in the 8 in the morning situation with the computation infrastructure is like this. One master node and two core nodes that actually have to live over there in order for you to have a cluster. That's our long-running cluster, and we also call it, because it runs for indefinite time, we also call it a LeBron cluster. During the night, when actually computations start, it autoscales, and a couple of more clusters appear in our infrastructure. When the computations are done, when data is in its final destination, ready for our business intelligence tool, this is what happens. We are back to minimal. And how much does this cost? No more than this. No more than $30 per day. So I think how we achieve that is we use the autoscaling. So we are always at the minimum of what we actually need. And we are using spot instances. That's basically kind of using the Amazon feature that you are bidding for the instances that you want to buy, that you want to have. And you're bidding, basically you are offering some amount of money, and the Amazon says, okay, you want this, you are getting these instances, that's okay. But what happens if somebody offers more, or if there is not enough of those instances? Then you're not getting those instances, yes. But then you ask me, like, but then your computations cannot run. What happens then? That you create a spot fleet. You are bidding for several types of the instances. So if Amazon doesn't have enough of instances of a certain type, you are getting others, and then your computations still run. So that's how it looks like. And so before we continue, I want to tell you the full scale of these clusters. So during one night when we are doing the computations, we have, I think, 5 clusters, which the biggest one reaches around 50 nodes. And those smaller ones go from, let's say, 5 to 20, 30 nodes. So in total, I think that during the night, we have an infrastructure of around 100 computers doing stuff for us. And when I'm sleeping nicely during those nights, and because I don't maintain anything. And when we arrive in the office at 8 a.m., we have 3 nodes and everything is in place. Now imagine that you have your data center, that you have your own infrastructure, that you have your own hardware that you actually had to buy. I think my nights would look different. And then while we were developing that product, that platform, we hit another problem, and that's job orchestration. So basically, we had to organize all those computation in a nice package, and we have to know which goes first and what comes after the previous ones. And we had to come up with a clever way to do it. First, we started with, okay, we approximately know how much each of the computation does, so let's start this one at 1 and this one at, let's say, 1:15, and then the next one at 2. But then soon things started to get complicated because we realized, oh, this one has to go in between these 2, but sometimes it's depending on if it's a work day or if it's a Friday or Sunday, the traffic really varies. So some of the computations can take, I don't know, 15 to 20 minutes, and during the rush hour, let's call it, it can take 45 minutes, and then how you're going to schedule that, because you were scheduling something at 2:30, but actually the previous thing finished 15 minutes late, so you got incomplete data when the next computation started, so it became all messy. So we said, let's orchestrate that somehow. And we were limited by time, because we had to wait for the previous day to finish, and we had to finish in a reasonable amount of time, so when people come actually to the office, they want their data in place. And how we did it? Again, using all the possibilities that we had in AWS. And at that point, that was my, let's say, the first opportunity to work with the Amazon services and in general in the cloud, and I was amazed. And right now, it's Amazon reInvent, a couple of these days in Las Vegas, and I'm following what they are doing, and these guys are, I think they are killing everyone. I don't know, it's like they are offering such a power for cheap money, it's crazy. I mean, cheap, depending on your size, but we are going to touch that also. So how our job orchestration works, we are basically made it reactive. So we are pushing the event at a certain time of the day. It wakes up our scheduler, and our scheduler is clever enough to say, okay, let me see who woke me up. Oh, this is this guy. Okay, then in that case, I have to activate these guys. And when the scheduler does that, the scheduler goes to sleep. No scheduler at that moment. Nothing exists. When computation finishes its work, it basically uses the S3 and the notifications that are built into S3 to wake up the scheduler once again. And then scheduler says, okay, now some different guy woke me up. What should I activate now? Goes through the list of dependencies, activates these computations, and in circle and in circle. If something goes wrong, we have a notification that goes to our Slack channel. And we know immediately after the problem occurred, we immediately know that something went wrong. And now the picture of our infrastructure that we are maintaining for this scheduler. When I say infrastructure, I'm thinking hardware that we are maintaining. And this is the infrastructure that we are maintaining for our scheduler. No infrastructure whatsoever. And the price that we are paying for that scheduler solution, zero. Lambda cost is almost zero for the whole month. And I think the cost for SNS notifications that we are sending is 80 cents. So I think there is no infrastructure, there is no solution that is cheaper than this at this point. Now, again, disclaimer, lambdas are used in Kazumo for other purposes also, and obviously we have enough small number of lambda invocations that we are not paying anything. But if you are moving logs, for example, from one place to another and you're using lambda functions for that, and you have like millions invocations of the lambda functions during the minute or the hour, then the price is going to be according to that. But for our use case, we are paying zero. And yeah, the breakdown of the whole solution of the big data platform. I will just take out some of the things. There are other expenses, but you will see the total price at the end. So this is it. For Lambda, we are paying nothing. For SNS, we are paying nothing. For storage, that's where we are pushing everything, like every single record that happens inside of the organization goes to that storage. That's 1K per month. For using the all computation power that we are using, it's 750. And for using the infrastructure of the pipelines, that's basically the Amazon service that you are using to compose the computation and actually saying this goes first and then after that push the data there and then copy data over there. So basically the composition of the computations, it's $80. And in total, we are not going over 10K per month. And I think the biggest price is actually the warehouse, the Redshift that I mentioned with the 10 nodes. It's around 2K. And now you're going to say, yeah, 10K is it's not cheap. It's significant money, right? Depending on who you are. Like if you are a small company, then I bet that you don't even need half of those things. But if you're a huge company and you have 10K monthly price for this and you say that it's too much, then you have a problem. And the problem might be that you are actually not monetizing your business. Because if you have enough of data, enough of computation to create this price for a month, and that's too expensive for you, I don't know. I think you are having problems in somewhere else, some other part of your business. But here is the counterpart of it. And I was actually part of one of these kind of organizations that have the data center and that maintain all this stuff and actually tried to migrate to AWS, and then eventually they said it's too expensive. So these guys, you have to have people. And you have to have people that have a certain know-how, and that's not cheap. Maintaining Hadoop clusters and in general big data infrastructure, that these guys are not cheap. And you have to worry about the team size, for example, because there are two of us, and I'm fine with when my colleague takes sabbatical for a month in India or something. I'm cool. I did that already twice, so I lived enough long to say that he went twice in a year for a month-long vacation, and I'm still here to tell you the story about that. So it can be done, right? So two or one guy actually maintaining all of these things. And with that team size, you wouldn't be able to have two guys in the team. You would have to have, let's say, I wouldn't go without 6 or 7 guys. And these guys are going to be very, very expensive, and you have to take into account their working hours, so they would have to go to work in shifts. So they are probably not going to be 7 guys, but more like 10 guys, because some of these guys have to work overnight. And you have to pay for them for their own call, so when they are like on Sundays or Saturdays. And then you will have to pay hardware. And yeah, everybody says like hardware is super cheap these days, but no, it's not going to be that cheap when you need 100 computers to actually deliver the computation power that you need. So the problem with owning your cluster here is that you cannot auto-scale, right? You have to have the maximum of computing power that you actually need in order to produce that. You can go like, if somebody says, yeah, we need 100 computers for this, and then I don't know, the people with the money says, we are going to do that with 30 computers. Yeah, okay, but then it's not going to be finished until 8 a.m. It's going to be finished at noon. So explain that to decision makers that they have to wait for lunch break to make decisions, right? And now this is all fine, right? We reach the point that we have a cool infrastructure, mature enough, and it costs 10K, which is nothing compared to marketing costs, for example. Marketing costs are 2 orders of magnitude, I think, bigger than this. But then there is just enough time to tell you the war story, because I don't want to give you like the silver bullet solution. The war story that happened 2 weeks ago, and that really I'm still feeling the consequences of it. So the war story is related to the Lambda scheduler that we had. And there is one detail that you have to know about how Lambda service actually works in Amazon. Now, the Lambda functions are basically pieces of code that you write and you deploy them to AWS. And imagine like they are small Docker containers somewhere, and when the event happens, they are woken up really, really fast, like in an instance, in less than a second, and they start working and start processing your message that actually triggered them. But there is a queue that is feeding those messages to Lambda service. And it's unfortunate not to know that that queue is shared for all Lambda messages in your account. So basically, if you have 100 Lambda messages, all the messages that are running through and invoking those Lambdas are going through one single queue. And if that queue gets stuck, all the messages are stuck. All the Lambda functions are stuck. They are not getting their messages, right? So what happened is that the other team that is not working with us deployed a couple of Lambda functions and said, okay, these are not high priority Lambda functions. We are not going to be so detailed about monitoring them. And they didn't. And what happened is that the number of errors in invocations of those Lambdas skyrocketed to the several thousands per second. And again, what happened? Lambda, as an AWS service, has a built-in retry. So for every error invocation, you get a retry, and it tries 2 times. So you have actually 3 invocations. None of them succeeds. And then you multiply that with the number of errors on that Lambda, and then you get a queue that is blocking all your Lambda functions in your account for 4 days. So yeah, it can be cheap, right? It can be cheap. It can give you the opportunity to scale up your product and to build amazing things super fast, but you have to be really careful and you have to know how things actually work in cloud. So yeah, with that story, I want to thank you for being here, and I hope you liked the talk. Now, questions? No questions. So that can mean only 2 things. Either I was brilliant or I suck. And I know I'm not brilliant. Yeah, could be. No questions? Okay. In that case, you can find me outside if you come up with some questions. Thank you very much.